Hello all, you are watching my project demonstration for the course Pattern Recognition EEL 6825 and my topic is based in anti-spam filter. So let's start with the definition of spam and what is its impact. Spamming is the abuse of electronic messaging systems to send unsolicited, undesired bulk messages. And spam messages can cause personal data to be stolen or cause other malicious activities in the system. And a recent study says that more than 80% of the total messages that are sent over the internet are spam messages. So here are few popular spamming techniques used by spammers to trick the users. We often see offers in the spam emails, offers like 80% discount in buying shoes or marketing through spamming. Companies market their business without doing genuine online marketing, or story building spam email messages. Spammers build a short story and ask people to share or donate something. So here are new trends in the world of spam: use of dynamic zombie botnets. Spammers see a huge potential in botnets. So they created alliance with hackers to use botnets for few minutes or hours to send bulk email spam messages. Image spam was introduced in the early 2006. So before that, spams were only text-based, and image spams were more graphic in nature and that cannot be detected by the text-based content filtering. So the solution was optical character recognition. Then fuzzy images were introduced, adding noise and distortion to the image. And after that, repackaging images as a PDF. So instead of embedding the image within the email itself, they repackaged it as an attachment. So the solution was filters that analyze the body of every PDF file or the every attachment of the mail to classify it as a spam or ham. So here's a graph that shows the number of email messages per month over time. We can see that it's not always increasing over time. Around 2002, the volume went up and then decreased. So several factors may have contributed to this change: new strategies used by spammers or new anti-spam filtering techniques. Solution. So we can see that spammers are constantly trying to stay one step ahead of anti-spam software vendors. So the solution is to use multiple anti-spam techniques, including Bayesian filtering, filtering for images, and filtering for attachments. Types of filters: list-based filters and content-based filters. List-based filters maintains a blacklist or a whitelist based on the sender's email IDs or the IP address on the IP addresses, and the mails are blocked if they are found in the blacklist filter. Content-based filter scans the entire content of the message, and few examples are word-based filters. Keywords are used to filter the message, or the rule-based filters, or the Bayesian filter. So the real goal of the anti-spam technique is not how much you can stop, but how much you can stop without blocking a significant amount of legitimate mail. So the aim is to keep the value for false positive to be minimum. Good filter should be strict enough. So about the Bayesian spam filter, it parses the content of the whole message. It is self-adapting and it can be used for any language, and it is very difficult for the spammer to fool a Bayesian filter because it keeps adapting itself. And my results also emphasize that content-based statistical filters have so far proved to be the most successful method in dealing with text-based spams. They make fewer mistakes. So Paul Graham in 2002 suggested an anti-spam filter technique using Bayes filtering theorem. So here in the formula, probability of message that it is a spam knowing that the word is in it is computed by probability that a word appears in a spam message and probability that word appears in ham messages. In my spam filter implementation, these probabilities are calculated using this formula, where B is the frequency of the words in spam message and N bad is the total number of words in the spam dataset, and G frequency of the word in the ham dataset in the good email messages, and N good the total number of the ham dataset. So B over N bad is a bad factor and G over N good is a good factor. So given a spam message, a word appears in it, that probability is calculated using this formula. So algorithm for spam filter. So the step 1 is training the spam filter. It reads the trained dataset spam messages and ham messages, tokenize its content on every non-word characters, and build the two data structures where it stores the word and the frequency, storing the word and its frequency count in the non-spam dataset or the spam dataset. So after calculating the frequency of every word, a probability map is created to store the word and its probability that email containing it is a spam. So that is, given a spam message, a word appears in it, or given a ham message, word appears in ham in that mail. And that probability indicates that if it is 0.1, it's a non-spam word, if it's 0.9, it's a spam word, 0.5 is a neutral value. And the frequency for the good words is double to avoid any false positives. Step 2 is classifying mails. Classifying mail is reading a mail from the test dataset, tokenize its content on every non-word character, then retrieve the for every word occurring in a mail, retrieve its probability from the probability map that we created in the previous step. And if the word is not found in the both data sets, assuming that the word is innocent, or if the word is found only in the good data set, then giving it a probability of 0.1, and if the word is only found in the bad data set, giving it a probability of 0.9. After computing probability of every word, the program computes the deviation from the neutral value, which is calculated using this formula. After calculating deviation, it sorts on the basis of deviation, and a tree mapped sorted data structure is used to store it. And the top 25 words in the tree map are used for computing the probability for an overall mail. So P1 here is the probability of the first most interesting word, and Pn is the probability of the 25th most interesting word, and P is the probability that a mail is a spam or ham. So after computing the final P value, it is compared with the threshold and program classifies it as a spam or a non-spam mail. It computes the statistics, error percentage, false positive, and the false negatives. Step 3 is adaptation. So while it classifies new mail, so it tokenizes its content and it reads a word, and every time it reads a word, it adds it into a good and bad data set. So it updates the frequency of the count in the good and bad data set, and after classifying every 50 new mails, it recomputes the probability map. So that's the way it adapts. According to the email messages it is classifying. And the last step is it displays results. So implementation of Bayesian filter, here are a few points to note. The program is written in Java language. The train and test messages are kept in two separate folders. each having two subfolders, one for spam and one for ham. And it is observed that the filter cost performance improves as the number of train and test messages increases. All words are independent. All numeric values are ignored for computing probability. The words less than length of 3 are not considered. String is tokenized based on non-word character. Precision for double value is configurable and it is configured as 5. And the most interesting words is configured as 25. Train and test dataset are mixed sets including hard hams, easy spams. And the dataset is downloaded from the two websites listed here. Configuration file, here is a configuration file which is used to create different test cases. Here the most interesting word count is set to 25, the threshold is set to 0.9, and the good token weight is 2, the path to folders, and the size of the data to train and the size of the data to classify. So here is the example, here's a part of the output of the spam filter. High probability words are listed here and the low probability words are listed here. High probability words like direct, deposited, free pick lotto, make money at home, amount, 1,000 per week, etc. Low probability words are good, busy, writers, crash, unfortunately, etc. This slide shows the size of test and training datasets. Total size, total of 8,000 email spams, and test dataset total of 7,000 emails. Results. In the results we can see size of the training dataset is 1400, which is quite low, and size of the test messages is 6,000. So to classify 6,000 it took 48 seconds and there is only one ham classified as a spam and there are 222 wrong classifications of spam mails and the total error percentage is 3.1. So we can see that error percentage is low as compared to the training dataset. This is because the email spam filter program, it's adaptive, so while reading 6,000 messages it adds every word into its good and bad datasets, and after every 50 emails it recomputes the probabilities. So even if we start with the less training data, it adapts itself. So because of that, total error percentage is low. In the second output, we have training data 8,000 but size of test message 1,600. Time taken is 13 because only 1,600 mails are classified. And there are 2 false positives and 177 false negatives. And the total error percentage is 11.7. There are 2 other test cases for different size of training data and size of test messages. Comparison between filter techniques. Several improvements to Graham's algorithm were proposed by Gary Robinson. He proposed a new formula for calculating probabilities for rare words, and he used all the words in the email to calculate the probabilities instead of just 15 most interesting words. So conclusion, spam is an ever-increasing problem. The spammers are constantly examining the latest anti-spam techniques and are outsmarting the static methods of fighting spam. And the real goal of anti-spam technique is not how much spam you can stop, but how much spam you can stop without stopping a significant amount of legitimate email. And lastly, obviously users need to protect themselves, and for the moment statistical filters are most promising method for this purpose. So next step is code walkthrough. Here is a website from where I downloaded all the test dataset. It has hard ham, easy ham, spam, and This is another website. For every year, this dataset has spam messages for every year. So here's my code. It is well documented. So the first step is reading settings from the configuration file. This is the configuration file. These are the two test and train folders. This is a sample spam email. This is the content of the spam email. And this is a ham non-spam email. Configuration file, where the threshold is 0.8, most interesting count is 25, and the size of input 2000, and the size of emails to classify is 3000. Train algorithm, it reads the settings, prints the settings, train the spam filter. Training spam filter includes calculating the frequency of words and then computing probability for each word, and then classifying. Step 4 is classify all mails using Bayes' theorem. In classifying all mails, it finds interesting words and all the words that are numerics are ignored, or if the word length is less than 3, they are ignored. This is the code for self-adaptation. Every time it reads a mail, it adds it. Every time it reads a mail to classify it, it adds the data into the good and bad dataset. And after every 50 mails, it computes the probabilities again. Here is the deviation calculated. Deviation from 0.5 to find 25 top most interesting words. Here is the final p-value, final probability of a mail is computed. It is compared with the threshold and a mail is classified. Compute probability for each token. It is called again after every 20 mails it classifies. That's the way it adapts. Let's run it. So it prints all the configuration values, the size of the training dataset, and all the spam emails classified incorrectly. So here comes the final result. It took 30 seconds to classify 6000 emails, and false ham classified as spam is 0 and false spam classified as ham is 195. So there are 195 spam emails which are classified as ham, and the total error percentage is 3.25, which is quite good. So the possible deviation from the result might be because of the tokenization of the string content, or maybe because I tested with the hard spam messages which are difficult to classify, and my dataset is not too big. So that ends my demonstration for the project. Thank you.